our primary instrument is the Solar Spectral Flux Radiometer, and it measures the solar spectrum, energy that is transmitted from the sun to the Earth, and then also the energy that is reflected back by the Earth. And we measure that as a function of wavelength over almost the entire solar spectrum. Now, our eye only sees in a small, narrow band of wavelengths, but the sun emits over a much larger wavelength range. We also measure the emitted radiation from the Earth, what we call the thermal radiation, and those are in wavelengths much longer than the solar radiation, and of course you don't see that. We're primarily interested in clouds and how clouds affect the energy balance of the Earth. So how much they absorb and how much they reflect solar radiation. In this particular project, ATREX, we're looking at very thin clouds. They're called subvisual cirrus clouds. They're ice clouds that occur very high in the atmosphere. They're called subvisual because if you were to look straight up, you wouldn't know they were there. However, from things like LIDAR, lasers, we know they occur. We know they're very persistent and widespread. And this is one of the really big unknowns in climate science is clouds and what they'll do in terms of how they'll change and in terms of what fraction of clouds we'll have in a warming planet and what types of clouds. And so we can make measurements to tell us something about the cloud properties and how they change the reflection of sunlight.
Basically, the system consists of an electronic box that has two sets of spectrometers. The spectrometers measure wavelength, electromagnetic spectrum wavelength from about 300 nanometer up to 2200 nanometer. What we do measurement of is what we call upwelling radiation from the ground in the atmosphere below the aircraft, and then also measuring solar radiation from the atmosphere above the airplane. So therefore we have two sets of what we call light collectors. They basically trap all the photons from the atmosphere, either reflected off particles or cloud from the atmosphere or reflected other things on there. So this is the native light collector, and you can see that this system itself is a passive element, and it has a what we call an integrating sphere that traps the photon from the atmosphere, and then also is protected with a quartz dome. From there it goes through a set of fiber optic cable that go up to our electronic box that has the spectrometers. So there's a similar setup for the zenith location light collectors. So this is the infrared what we call infrared radiometers. We call it a CG4. It's made by a company called Kip & Zollner. It measures radiation from around 4.5 micron up to about 40 micron. What we call the signal is coming from both the zenith location as well as the natal location, and it all go into our electronic box that has a spectrometer. It's located in what they call zone 46 on the Global Hawk. From there you can see that the fiber cable as well as the electrical cable go in the back of our electronic box, where they go into the spectrometer themselves. There's two sets of spectrometers, one for the zenith location and then the other one go with the signal from the natal location. We can get real-time access to our data system, which is part of the electronic box, and we're able to, through the KU communication, able to log into our system and also able to capture all the data file that we recorded while the aircraft is flying during the mission. And so when we get the data file on the ground through the GHOF workstation, which could be able to actually start processing it in near real time and able to present results to the rest of the science team.
Earth's temperature is changing, climate change, and clouds are one of the big unknowns in predicting how things will change. What types of clouds will occur, how often they'll occur, at what level they'll occur, whether they're ice or liquid. They can either act as coolers of the Earth or as net heaters of the Earth. So that's one of the big questions in this particular project, is how these thin clouds change the radiative balance of the Earth. And so getting some insight into how they form and what they do to the energy balance of the planet.